Good afternoon, everyone. I hope you are good. So before we begin, I think I need to ask if there's any questions from previous meeting or use of the app, and I attend to them before we begin the meeting. Okay. Then I'm going to proceed to share my screen. And we begin. Kindly let me know when you can see my screen.
We can see your screen.
Okay. All right. So the last time we met and we went through what we have here, we basically spoke about how the messaging lead, the message platforms go through Amazon SES and all of that. So for today, we are going to look at two places. The first one is how the message leaves the messaging platform and gets to Amazon SES. That is this part here. And then we are also going to talk about how the current code receives notifications and updates. So I think I have the current code here. So that'll be email. And if I remember correctly, it's a task. Okay. So for most of the email items, I think most of them looks like they are tasks. For send email verification, if you remember during last week's discussion, I remembered I mentioned that once a message is sent from here to here, you confirm to ensure the email has already been validated. So this is the sender email verification that's done on our side, where if we go, I'm sure if you access the portal and the user inputs a new email to be whitelisted, we send this email to make sure the user owns that particular email. Okay. So we have the Fire single email API here. I think that would be enough to that would be enough to click that. So I think I don't need to go through this and this and this and this, but probably this. Okay, so I think we call Fire email and yeah. Okay, so this is the first again. This email job callback. So we have the API email processor. So in the API email processor, there are a couple of things that are done. If I remember, I think email job is, yes, is a model of the email job. I take it most of the users here have used the new platform before. For every message that leaves the system, it's either an SMS job or an email job. So whether it's a single email, multiple email, scheduled email, or whatever, they fall under email job, and then they are specified later under that. So these are basically, I'm not going to go through a lot of this. There's, I'm sure you can read through this and understand. That's it checks if balance is available, enough balance for the user, and then the Fire email itself. So it checks if the user has enough email balance, right? And if there's enough email balance, we proceed to fire the email. So just a minute, it's been a while. So we create a statistics. So statistics is basically what we use for our reporting. You have to access this currently. We access we create a new job statistic in the model, and we have the total email jobs, total email, and then total emails. The reason we are able to do this at, I think, email creation is we are sending out the emails initially. So the data we have are the total emails, the total emails sent out and total filled emails. If I remember correctly, these total email fields are emails that do not match the email format. So for example, maybe it's not, it can maybe something like this. We have lots of filters that's supposed to catch items like that. But so this is just a field save. And then blacklisted emails, they all go under total emails fields. And all successful ones go under total email pending. So this is, let me look at this very well. Yes. So we create the statistics before we actually fire the email. So we have fire multi-threaded email here. And all this does is it uses multiple threads to fire the email. So that if it's 10,000, we have a thread of 8 and it's spooling through all those 8. Yeah, so that's all it does. So over here, we send out the email, we get a response and we pass the response over there. Okay. So one last thing, just to bring to your attention. We have what we call the email engine. So the email engine is a class that we dependency load with whichever email engine we are using, whether Amazon SES or Mailgun. And we let the connectors, that's Amazon SES or Mailgun, they've exposed the correct method for us. So all this, if later we want to load introduce a new connector, this is where we introduce a connector. And yeah, so this email engine basically loads the correct connector, and with the connector that we put on email connection, we fire the single email. Any question before I move on from here?
Yeah, I think I have one question.
Go ahead.
The email engine, right? We all know that the AWS one is an operational. What about the Mailgun? Is it an operational setup or just for demo?
Okay. So the Mailgun, if I remember correctly, the Mailgun's endpoints have also been created and all. So once we get the correct Mailgun API key, initially we're testing with Mailgun for some items. So the Mailgun is also set up. So once we load the correct Mailgun API key and we switch the connector, that will also kick in.
Okay. Another question. Now, is the Mailgun going to serve as a fault tolerance?
Could you come again?
I'm saying that do you advise for Mailgun to serve as a fault tolerance?
To serve as a
fault tolerance? Do you advise for us to use the Mailgun as a fault tolerance?
Is it fault tolerance?
Fault tolerance. Like a backup.
Oh, okay, yeah. So the reason why we are not using Mailgun, and Francis can correct me if I'm wrong, is it's a business decision. It's currently a business decision. If we want to use Mailgun as like a backup or fault, a fault tolerance thing, we would need, yes, it's possible. I think what we have to do is basically what we have as the email engine, if prep connection fails for connector 1, prep connection basically it's a stage of process where we try to initially connect to the third party. So whether it's Amazon SES or Mailgun. So if that fails, then we can, change over to the backup one. However, that's something that's not implemented, but yes, Alex, it can be implemented.
Okay. I think another question. can we configure another SES in a different zone or a different region? And if that is the case, if you can also work out.
Okay. Sorry. Yes, it is possible to configure a different SES, and I'm going to take you through this SES. So this SES basically, this is what basically makes, okay, so I'm using SES and not SES. Okay, yeah. I think I remember that I mentioned I was using SES and SES V2. Sorry, please, a minute. Okay, yes. So over here, all we need to do, so to do something like that, to use different SES models, what we can try to do is we can try to override, okay, I don't think we are supposed to do this. This should ideally only happen in one part of the application. So this is a cleanup you guys can do. But what we can do is to do that, we will need to override this init, right? So that if we have region 2 defined, we can have the init pick up, you know, this, and then have a different AWS instance. So maybe a new class, maybe we call it backup Amazon SES. Or if we have an idea to have maybe multiple Amazon SES, then we create a class dynamically as we move along. But the idea would be once we overload this init with the new keys for the new regions and all of that, we would then be able to connect into that specific SES instance. I hope that answers your question, Alex.
Yeah, I think we'll take it from here. Thank you very much.
Okay. Any other question before we move on? Okay. Okay. So also to answer a question, I remember Eric asked last week. He mentioned, is it possible to have different configurations for different users? And yes. So over here, you can see that we are assigning default configuration over here, where we set .default configuration set name. So if we have multiple configuration sets, we can set it over here before sending out the email. Yes, so it allows for quite the amount of. So basically, if you want to use a new email engine, if you want to use a new email provider, what you need to keep in mind is for the email engine, it expects a couple of methods to be exposed. That is the prep data method, the fire signal method, and the validate email method. So once all those are exposed and you write a specific code to handle each engine's uniqueness in providing the ID and all of that, then we proceed with that. We can easily integrate, and I think the email engine to use, I think we set it in configuration or something like that. So yeah, yes, email aggregator. We set it in settle.email aggregator, which is the configuration. So yeah, that's so that's it. So just to go over one last time, we pull the data, we pull the data when we go to Fire email. We check if there's enough balance available. Then we create a statistic. So the statistic is basically a model. Let me just go there. So create statistics. Let me just go to that particular model where it sits. There it is. Okay. Great. So as you can see, for each email job, for the various statistics pending, sent, rejected, delivered, bounce, complaint, clicked, open, render failed, failure. They are all in here. So that way, when you're pulling reports, it's just one row that we come and pick the data. Yes, so once we create a statistic, then we fire the email and then we move from there. It works similarly for firing bulk email. The only difference between firing single email and firing bulk email is with a bulk email, we use the multiple threads we have so that we can fire as many as possible with a max worker count of 16. Yes. This max workers is just, this number was just done through observation, and whether this was what worked best for the server we had. Yeah. So for bulk, that's the only difference. We have multiple threads shooting off emails at a time. And as I said, since we log everything, we log when the bulk email started and when the bulk email failed. Sorry, not failed, when it was completed. And then we also, so each job or for the bulk email, each one that goes into a thread, I think it's either 10,000 emails. Yeah, let me check chunks. Yeah, so it's a setting, but I think the settings are 10,000 emails per thread. So we fire 10,000 emails per thread. Yeah. So if it's 100,000, we spin up 10 threads, and then those 10 threads run simultaneously. Yes. So that is basically this part. So last week, I took us through the SNS, that's the simple notification system, and we saw the multiple endpoints. So the endpoint for the email, if I remember correctly, let me see if I can find it. For the email, and this endpoint receives everything. So there's endpoints, so there's the Amazon SES lots of endpoints. Yes, okay. So we get the data from this. If I remember correctly, the reason why I was doing this was I really couldn't determine. I'm sure it can be determined now. So maybe it's a part for optimization, whether it was coming as a get or a post. So I just placed put there. And as you can see, it's basically the same code. Yeah. So the HTTP response I'm sending is here, but anyway. So once we get an endpoint, we receive the body. We decode it in UTF-8 because I think when it comes in, it's binary encoded. What was the reason? I remember, oh yes. So there is a fuck up on Amazon's side where this is a JSON, it's a JSON information they are sending. However, if you expect a JSON response, because Amazon does not have the JSON view header in the response they are sending us, you will not be able to grab the data. So what's happening over here is we are receiving as a normal get, and then we are encoding it into a JSON and then working it from there. So yeah. So this is an Amazon reference I think we just created to match. So if it's sent, the status from Amazon will be sent, rejected, delivered, files, complaints, all of that is rendered failure. So we load the data as a JSON, and then we check if the notification type is in here, right? And if it's not, I remember, if it's not, we dump it somewhere. Let me see where we dump it. Yes, email DLR undefined status, because it means it's a status we are not aware of. However, we need to track it. So if ever this is populated, if ever this this log file is populated, that means Amazon is sending us a new DLR, which we have no idea of and which is unhandled. This helped us catch a couple of errors which we were not aware about. Some had to do with the domain. Remember, I also spoke about people could whitelist their email address, but they couldn't send from that domain. This helped us catch that error. So I think what we do is we try it X number of times. Yes, so that's the number of times. We try to see, probably there may be an issue, there may be a race issue, it's not having access to this, even though we are using an append over here, so you should still have access to it. So we try 10 times. If it's more than 10 times, you're not able to push the update, then we push it here. So this part of the code is where I mentioned the other time, we will cost ourselves a denial of service. Because what's happening is, imagine us creating 10 threads and we are sending out 10,000 emails, right? So, what's you? Just a minute. I can still use this. Okay. So imagine we have 8 threads, right? And for those 8 threads, we are sending out 10,000 emails. So let's say for each of those 8 threads, we are getting, we are pushing out 100 emails per second, right? So that's basically 800 emails per second. So for these 800 emails per second, they would all come back with statuses. And I remember I said the other time, for Amazon, we have sent, let me quickly check. Delivered, right? We have rejected. So all these 800, most of them would first have the status and then would graduate to the status and, can go into bounds, complete, click, reopen. So that means for each second on our server, we will be getting, so let's say everything works as it is, but in the real world, it doesn't work that way. We are getting 800 back. And if it's more than one plus going on at the time, we can get as much as maybe 1,600 hits on our server per second. And this is also happening whilst our server is being used normally, right? So imagine an SMS blast is going out at the same time, email blast is going on at the same time, there's a USSD voting max out at the same time, they all are running through the same Apache instance. So this can really balloon. So what's the idea here is we want this to touch and leave as quickly as possible so that no thread is held for more than at least 1 second. And this accomplishes that. I think the last time I checked, it was 53 microseconds. And it's enough time to release the thread for a different request to handle. So the way this happens, and also this is similar to the SMS updating is we push everything into a file, right? We don't open and read a file and find a point. We just append it to the file, to the end of the file. So we don't care. We're just pushing it to the end of the file. So that as soon as it touches the server, we are getting this. Another way we can work with this, I've forgotten the reason. Yes, I remember the reason. Another way we can work with this is we can take this out entirely. Since we have a Redis cache installed, we can push this into a Redis cache. However, the reason I decided not to go with the Redis cache for this is in case the system goes down or something, we need to restart the server, which is really, really rare, or those in weird instances like that, we are going to lose the data in the Redis cache. So that's why I want us to push straight into a file. Initially, what we were doing here was we were doing a DB connection, and trust me when I say that was a really shitty approach. So yeah, we push into a file. So what happens here is endpoint hits the URL, we route it to say Amazon email DLR, Amazon email DLR pushes into a file, and that's it. So for the email engine too, for each unique engine we use, so currently there's the Amazon SCS endpoint. I don't know if the Mailgun is here. Yes. So we also have the Mailgun endpoint that handles Mailgun endpoint. You know, each company will have different endpoints, and each company will have different ways we are supposed to parse the information that comes. The idea for this endpoint is it touches and leaves the system so that we have as many threads as possible for the Apache to continue working normally. Yes. So any questions on this part before I move forward onto how we actually update the DLLs in the DB? I hope it makes sense. Yeah, nobody's responding. Or should I
Okay.
go right again?
Alex is about speaking.
I think it's clear. My question is,
Mhm.
I saw sound in the function around. If you can clearly define what that for us.
Okay, so which functions
Yeah,
are we
the
talking
DRL
about?
update. Yeah, the DRL update.
This
Yeah,
particular one?
yeah, see Amazon, yeah, that one.
Okay, so what this function
The
does,
report,
yes, so this is what, this is
the
the
count,
content.
the count variable.
Which variable?
The count
Okay,
variable.
okay, great,
The
okay,
count variable in the function.
great, okay.
Yeah,
So
yeah, you can go back on that.
would do. So these are the, I would say, the different statuses, the different available statuses for all emails that leave the system that we are aware of. Send, rejects, delivery, bounce, complete, clicked, open, and rendering failure. These are what we are aware of from Amazon. So if all is good, this is the code that would execute. Because if you check, we are looking at notification type in data.keys, right? And notification. So if notification, yes. I will not go into the history of why we're using notification type and events type over here. There was some messed up EEB. So that's why we have both notification and event type here. But basically, we check if, so Amazon has, let me see if I can show it here. Okay. So probably the sample SMS notification that comes would be something like this and more information. So when we receive a JSON body like this, we check if, you know, the keys of the body. So as you can see, we are losing the string data that we got from Amazon. We have it as a JSON body here. So we check if notification type is there. The reason we're able to do this is because we know the structure of how the response from SMS looks like. So we know we are searching for notification type or event type. That's what we are searching for, notification type or event type. So if notification type is present, notification type will be one of these, or event type would also be one of these. So all this does is, whether notification type or event type, we match the correct one to whichever one we have here, right? And then we save it. For this part, for the exception part, if a notification comes from Amazon SNS, however, there's no notification type or event type, right? Then what happens is we try it 10 times. The reason I remember behind the trying it 10 times was there were instances where at the time this was unable by this, I'm talking about this execution, this code execution was not able to access this file. I have a feeling that this code is now redundant. but it's better to leave it in as a catch to catch any issue. So if there's no event type or notification type, but our endpoint is still being hit, right? We try a couple of times, probably maybe this file was not available at that time. And each time we try it, we increment the count, right? However, after we try 10 times, and I believe there's no point. I mean, we can even reduce this to 5. I think some people have to reduce it to 5 now. But after we try a number of times and it still doesn't save, then what we do is we push it into this file called email DLR undefined status. So it's a DLR or notification we are getting from Amazon SNS. However, with our current knowledge and our current code, we do not know how to group it. So we would need to access this file manually to see what's in there and then see how we would handle it.
Okay.
Yes.
I think we can proceed from there.
Okay. Okay. So I am proceeding now. I'm not going to go over scheduled email tags because that falls under, yeah. So imagine we send out 100,000 email or 500,000 different clients, and we need to update the DLRs. If we look at the way it's set up over here, we can see all those information. So let's say we sent out 500,000. So there's the total emails. Let me see. The total emails. $500,000, right? So each email goes through at least 3 different stages. So that means at the end, we may have oops, sorry. We may have as much as this amount of DLRs waiting to be updated, right? So that's a 1.5. And this is variable. Yeah. So all these 1.5 DLRs are currently in this file. Agreed? I'm kind of searching for a response here. Okay. So what we do is, okay, so what we do initially is to save the DLRs, we split these DLRs into chunks, right? And then we have a task that will pick up those chunks and start saving it chunk by chunk. So that's what this does, splits DLRs into chunk. So let me go into the code itself. Yes. So what it basically does, the split DLR into chunk are one. Oh, yes. So I think, Alex, to also shed more light on the question you asked, during this activity is also why that loop is done here. So that during that activity, when this file is not available, by the time it's looped about 2 or 3 times, the file become available again because of splits to chunks. The first thing split to chunks does is we get a working file name, and we need a working file name that is won't repeat again. So we use time zone dot now to the microsecond, and we use prefix. I think we use the prefix to determine, yes, email. We know the difference between email and I think SMS, I believe. Okay, so the first thing we do is And the file name too, yes, because email is email DLR, and I think SMS is DLR. So this works for both SMS and email DLR. Yeah. So the first thing it does is we replace. So we take the current DLR, which contains the 1.5 million SMS DLRs, and then we create a new file called working file name, where working file name is time zone.now to the microsecond, so we do not have a repeating name, right? So we have that now. So we have that, and then what's it called? The DLR file is created again to allow more DLRs to happen. So the DLR that contains this 1.5, the name has now been changed to maybe, let's say, 31, 01, 20, 23, 13, 43, 43, 44455. Something like this. Yeah. So this is the new name of the file, and it contains the 1.5 million. So we take it from there, we place it here, and then that DLR is reset to 0. And I think, if I remember correctly, this runs every minute. Let me confirm. So the chunker runs every minute. Let me quickly confirm that. Yeah, the chunker runs every minute. So every minute, we pick up the file and push it into a new file and leave that file to receive more data. Then helper file name.dlr. Yes. So once we replace the data in here, we create a new file, and then the data is pushed into it. Then the next thing is we chunk the file. So over here, I think we've set the file size to 200, right? So all this does is, for this 1.5 million, we create a lot of other DLRs, which contains. So right now on the server, we will be creating 7,500 new files on the server. And each of the 7,500 contains 200 DLRs. There's a reason behind this, and we will get to it. Yes. The maximum size, I remember this file being, was, I think, I don't know, maybe 500 KB. But there's a reason why we are chunking 200 and not probably something like 1,000. So that's all this does. That's what this part of the code does. It reads the file, chunks them to 200 lines a size, and then saves the file name. As you can see, we open the file name, save chunk to files. If you come here, so open, we have chunk size as 200. So we are performing, so we load all the lines into memory, right? I mean, we can do something about this line over here, but we load all the files to memory, and then we just slice the list over here. We just slice the list over here. And so with each slice, we save it in this file. Yeah. And I think we number it. So it becomes, so if this is the name of the temp file, it now becomes maybe _1 for the first chunk, _2 for the second chunk, 3, 4, 5, 6. Yes. And we save those chunks. So that's what this task does. And then we log X number of DLR chunks created. Any questions on this? Before I move on.
No, no for mine.
Okay. So we have the task that's chunking, and now we have the task that is saving the DLR to database. So initially, and the reason why we're introducing ourselves was we're performing this task on every time the server, our endpoint was hit, but now it's been pushed to the back. So this, what this does, and I believe this can be done. So yeah, what happens is we pick, let me just quickly read through. So we have the cache, we set in the cache when we are, saving data to DB so that we are not running this task more than once, right? So I think this is run every minute too. This is run every minute. However, we check the cache to see if it's already running. If it's already running, we ignore it. But if it's not running, so as you can see, cache.get, if this key does not exist, defaults to false. So if not false, so that means if true, right? So if not, I think it's best if we change the name of this variable. Yes, so maybe I'll call it processing DLR, but it's on DLR processing flag. Yes. So once we start doing this, what we do is we set this to what's it called, saving email DLR, and we give it a time of an hour to get a job done. There was an issue I encountered. I thought I handled it, but looking over here, it looks like I didn't handle it. I'll talk around the engineers later. If I talk about it now, it might get a bit confused. So yeah. Okay. So we set a cache so that we know, so that anytime this function is called, this task is called, it already knows there's a process going on. So what this does is we get a list of all DLRs saved. By all DLRs, I'm talking about the 7,500 files, which each contain 200 DLRs. So this reads that directory, right? Takes all the file names over there, and then we sort. That is why we use this naming convention when we split the file into chunks. So that ideally, all DLRs that come in first will be attended first. So we sort over here, and then we process 100 files at a time. So that means for each minute this runs, we'll be handling, so this would take roughly maybe about, let me see, about an hour and 30 minutes for all the DLRs to be updated. So we pick the first 100 DLR files, we create a DLR class, and then we begin working on this. I'll go into the code and then we will look at the code over there. Let me see. So get distinct jobs IDs. Okay. So we process the email DLR file in this first multitask task. Yes. So let's read the process email DLR and see what it does. There's a lot of timers in there because I think I just wanted to see how fast they were and see how we could speed it up. Okay, so we have 100 DLR files we want to use, right? So over here, we have 16 threads span up over here. So those 16 threads will handle the 100 file. So each of those files would go through what we call process email DLR files. The whole idea is I do not want to process 1.5 email DLRs in one thread. Shit happens, anything can go wrong. If you are processing this and something happens, you will need to start again. You are not sure of which ones got updated, waste of space. However, if we just use 200, 200, 200 each, I mean, we can increase it to 1,000 too. That also works. So that's why I'm basically splitting these files into that. Yeah. So for each of those 100 files, which each of the 100 files contain 200 DLLs, we read all the DLLs, right? And then what do we do? So we load each line as a JSON, great, and then we group it. So for example, let's say, just a minute. I do not have access to the server, else I would have seen how a sample response comes. But basically, the idea here, right, is if it's coming from the server, I think when it comes from Amazon, if you remember correctly, when it hits our endpoint, we do not process it in any way. We just save it directly. So that means the JSON structure in this application, right, will be almost everything from Amazon that's here, right? But what we want are these two. And let me call this junk. It's not junk per se, it just has more information that we are not using here. However, what's important for us and for our application are the message ID and the status, right? So what we are doing here is we are taking the status in the compiled DLL key, and what we are doing is, so for a status like sent, right? For a status like delivered, for a status like found, we are creating a list of all the message IDs, where message ID refers to each unique email that was sent. Let me just say maybe message ID 1, message ID 2 are sent, right? Then we have message ID 3, message ID 4. And just to fuck around with your mind a little bit, message ID 1 can be sent, and you would also find message ID 1 to other bounced. Yes, it happens. The user may have bounced it or done it later. So what this does is so it's called compiled DLL. As you can see, we have DLL status that becomes the key. So the key is sent, delivered. That is barely bounced, sorry. Bounced, and then we do. For those who've worked with Python, with Django's models, I'm sure you are familiar with this. Or do I need to go about what this does? So what we are doing over here, what I'm doing over here basically is, this is 1.5 million, right? If you just write this lazily, as I initially did, you are touching the database 1.5 million times, which is ridiculous. So what's happened here is I'm writing an extra long query to touch the database once. And this is, so I'm writing a query. As you can see, this is an OR, right? And external ID. External ID is the external ID from the database. I feel like, just a minute, and let me show you where you can get that external ID. Let me go to models, and let me go to email job. So if you remember correctly, email job can be a scheduled job, can be a single email job, can be a bulk email job. However, it's individual emails that come together to form the email job. So if I'm to find a model that is called email log, you can see the email log. So this email log contains every single email that was sent. So for this blast, which was 500,000 emails, we would find 500,000 rows over here. They would all belong to that one email job, right? And all of these 500,000 emails would have a unique external ID. The external ID is the ID our third-party application provides us. So the ID from Amazon or the ID from MailChimp, so that we know for this email that went to user A on Nalo system, this is the email ID we use. However, on Amazon or Mailgun, this is the ID they assigned to it. I hope this part is clear. I should have mentioned this part a little bit earlier. I touched a little bit last week, but yeah. I hope this part is clear.
Yeah, it's clear.
Okay. So back to this DLL. So what I'm doing with this query is I'm building a really long query where the external ID, because if you remember correctly, when it hits this URL endpoint, Amazon SCS, or what it does is it just saves to a file, right? It has not searched in the database whether that record exists or anything. It just saves into a file. So the only way we will be able to relate what came from Amazon to what we have in our Nalo system will be the message ID. In this case, that's Amazon, right? Message ID. We would search for that message ID in XID. I think for this, I don't know, it might increase our processing time, but if we change this to, no, it's okay, this is okay. So what I'm doing over here is I get my dictionary. The idea is I get my dictionary in this way. So what I'm doing is eventually I end up writing a query like this. Updates. What I want to do is I want to write a query that says update email log, right? Set, what is it called? Status, right? Set status to send where message ID equals message 1 or message ID equals message 2 or message ID equals message, yes, message 2, as you can see over here. So that way, for the 200, if all the 200 is sent, I would have all the 200 looped into an OR condition over here. Otherwise, the other condition is I have to write 200 different SQL queries. So it's a different status. It just becomes, so if it's delivered, I have update email log, set status to delivered, the message ID will be this, or this. Then the same for bounce. So number of queries that eventually hits the DB would be the number of statuses available in that file. Should I go over this again, or you get where I'm coming from?
Yeah, I think for my side, I'm okay.
Okay. So that's what I'm doing over here. So that's what I'm doing over here. So if you take a look at it, for the first inputs is Q, right? So this is like a custom query, and then ORs. So I group them under the statuses, and then I do that. So when it's done over here, right? As you can see, this is the code that basically executes that. So the email log does that, and let me see. So I update this. So this performs the updates. And what does this do? Just a minute. So this performs the updates, right? So when this is come, email log is updated, and then job ID. I fetched the job ID here because I use it for something later. Oh, yeah, and this is why I add emails to blacklist, right? So I check if any email is bounced or complaint, I add it to the blacklist here. Unfortunately, it's 2 o'clock. We will need to continue this later. When there'll be another meeting this week, for the other meeting this week, I'll start the DLR process again, right? Just this part of the DLR process again, and we will finalize it and have questions. Any questions before a break? But that's the idea. The 1.5 million is broken down into chunks. The reason why it's broken down into chunks and handled that way is from past experiences, there were some instances where the SMS log does not exist. The email log does not exist. But the email log not existing is for, let's say, I sent out the 500,000 blast. Now that 500,000 blasts, at the time the message comes in, let's say about 400,000 has been written. I changed the way the code was structured for this not to allow. However, things happen. So just in case 500,000 has been written, there's 100,000 left. There's code that I've written, we'll get to it. But yeah, so we break it down to 200, we process it 200 at a time. If any of them fail, we try that file again in a while. Okay, I think initially it was 500. And yeah, so yeah, total lines process, if it's the same, I delete a file. But if I talk about it right now, I'm rushing, so I wouldn't have enough time to talk about it with you guys. So what I'll say is, I'll set more meeting time with Mina, probably Thursday or Friday, and then we complete this. Any questions before we break? One thing I can say to help you understand is if you have access to either the test bed or you can actually help me by getting me that information too, is find this file. Where is it? Be able to find this file, be able to see some of the data in there, and basically walk through. You can use JSON, it's a JSON, Postman to send a request and then walk through and yeah. But that's it. Any questions before we break? Okay, so in the absence of questions, I will let Mina know the next meeting time and we'll pick it from there, and then we complete the DLR scheduled updates and stuff like that. Yeah. Okay.
Okay, Fifi. Thank you so much.
Thank you for your time, everyone.
Francis is unmuted.
This week. Hello, Francis.
Oh, I was just saying, okay, noted.
Oh, okay.
Thank you, everyone.
Okay, bye.